Then the system and surrounding. One of the basic assumptions of thermodynamics is the idea that we can arbitrarily divide the universe into system and its surrounding. The boundary between system and its surrounding can be as real as the wall of a beaker that separates a solution from the rest of the universe. This one is telling us that there is a kind of a strong relationship between a system and then its surroundings. So we have what we call internal energy. One of the thermodynamic properties of a system is its internal energy E. Internal energy is denoted by capital E, which is the sum of the kinetic and potential energy of the particles that form the system. I'm sure you know kinetic energy, energy in motion, while the potential energy is a static energy. So the combination of the two will give you the internal energy of any system. So the internal energy of a system can be understood by examining the simplest possible system, which is an ideal gas. Because the particles in an ideal gas do not interact, this system has no potential energy. The internal energy of an ideal gas is therefore the sum of the kinetic energy of the particles. Now, the first law of thermodynamics can be captured in the following equation, which states that energy of the universe is constant. That is, energy can be transferred from the system to its surroundings or from the surroundings to the system, but it cannot be created or destroyed. So we have from the first law, mathematically, you can represent it as the energy of the universe is equal to the energy of the system plus the energy of its surroundings. Just like I said that the internal energy is the sum of the potential energy and then the kinetic energy. So under first law of thermodynamics, you can get our total energy to be the energy of the system plus the energy of its surroundings. So from that place, the energy of the system is equal to Q plus W. Here, this your Q stand for heat, while W is the work done. Now, the sign convention for the relationship between the internal energy of a system and the heat gain or loss by the system can be understood by thinking about a concrete example, such as a beaker of water on a hot plate. When the hot plate is turned on, the system gains heat from its surroundings. You know, the heat is not coming from what you have inside the beaker. It's coming from outside. It's coming from the gas or your hot plate. So that means that the heat is coming from the surrounding. So as a result, both the temperature and the internal energy of the system increase, and in that place the energy will be positive. So that means that the total energy there is the internal energy of the system, that is the internal energy of what you have inside the beaker, and then the energy coming from the hot plate will now give you the total energy. So when the hot plate is turned off, the water loses heat to the surroundings. When the hot plate is on, the system is gaining heat from the surroundings. But when you now put off the hot plate, then the system will be giving back heat to the surroundings. So when the hot plate is turned off, the water loses heat to its surroundings as it cools to room temperature, and in that case the E will be negative, still referring to endo and exothermic. So that means during the process that the system is getting heat from the hot plate, that means the system is absorbing heat, that is endothermic. But when you put off the hot plate and then the system is now giving out heat, that means heat is evolved, giving out heat to the surroundings, then that is exothermic. So, in conclusion, the relationship between internal energy and work can be understood by considering another concrete example, which is tungsten filament. That is the one inside your light bulb. When you look at those light bulb, not this energy bulb now, the the former old bulb, you can see inside it that there is a tungsten filament inside. See what tiny metal inside. Now, when work is done on the system by driving an electric current, and you see the current coming through the wire is going into the system, that is going into the bulb. Now, the system becomes hotter, and then the energy there will be positive. That means the bulb is absorbing energy from the wire in form of a current. So in that place, the bulb is taking energy from the wire. So the system is getting energy, and in that case, that's energy there will be positive because it will be endothermic, is absorbing. And then eventually what happen, then you now see the filament will now become glue, and that is why you see your bulb coming up. Then also when you switch off, what happen, you see it, the bulb, the light will go off in a gradual process, and in that case the system is now giving back the current to the surrounding, and in that case the energy will be negative. So thank you. This is where we are going to stop today, and like I said in the last class, if there is any aspect of this topic that is not clear to you, try as much as possible to ask questions. Get across to me and be free to ask your question. So till next class, when we meet again, stay safe.